Hi there. My name is Levi Casto. I'm a senior here at the University of Washington in the program on the environment. And today I'm presenting on learning from the forest chorus, the indicator songbirds of the Olympic Peninsula, which is a little presentation that I've put together on my independent research project that I've completed over the past quarter. Before I begin, I'd like to thank and acknowledge my site supervisors, Dr. Theodora Minkova and Lauren Keene with the Washington State Department of Natural Resources, as well as my faculty advisor, Dr. Tim Billow, here at the University of Washington, also in the program on the environment. So let's begin. So you might be wondering, why should we listen to songbirds? Well, for a little bit of background and to answer that question, I can tell you a little bit about forest management organizations. These organizations have a vested interest in monitoring the qualities of their forest, whether it's how their trees are growing, how old they're growing, what qualities the forest habitat has, so that they can make better management decisions. The more they know, the better the decisions they can make. And one way that these forest management organizations can learn a little bit more about their forests is by observing which species of wildlife are inhabiting their forests. So one specific category that they might look at are songbirds, because they utilize trees for nesting and for feeding. And there's quite a large array, a diversity of songbirds, so they can teach us a lot of different things about specific habitat and specific feeding needs. There's a lot of things that we can learn by looking at which birds are inhabiting a certain part of the forest. So historically, what management organizations have done is they'll pay biologists to go sit in the forest for a little while and observe which songbirds are present. So either looking at them or listening to them and writing down the songbirds and how often they're showing up in order to make this occupancy data that indicates something about the forest stand. However, this is a pretty resource intensive and rather inefficient method of doing this monitoring work. And so there's a new technology and a new methodology being employed recently, which is called passive acoustic monitoring. The basic idea of passive acoustic monitoring is that we put recording devices, little microphones, out into the forest. They record songbirds' songs, and we listen to those recordings and mark what songbirds are present in those recordings. And that gives us an idea of which ones are living in that area of the forest. With this new technology and methodology, though, we need to kind of assess our whole research design. So that's part of what I'm trying to accomplish with this research. My research objectives are first to develop considerations for indicator species selection when using passive acoustic monitoring. So if we're going to be using this technology to listen for birds, we've got to make sure that they're birds that we can identify based on their song, birds that are going to be singing enough for us to hear them, that sort of thing. So first is to develop those considerations. Second, I was also focused on identifying the most relevant criteria for indicator species selection in anticipation of climate change on the Olympic Peninsula, because that's going to be a major game changer in this sort of monitoring research. And then finally, comparing the new criteria that I create against DNR's current indicator species list to see how well it holds up or where we can improve. So a little bit about my internship with the Washington State Department of Natural Resources. I worked with Dr. Theodora Minkova and Lauren Keene's research team over the past quarter. And the brunt of my work was manually validating these passive acoustic monitoring surveys for indicator songbird occupancy data. Up here at the top of the slide, you can see there's a spectrogram of a recording of the morning chorus on the Olympic Peninsula. And you can see there's a lot of noise going on, a lot of songbirds. Right here at my cursor, you can see there's a dark-eyed junco here. Down here, there are American robins. Up here, looks like it might be some sort of warbler, probably a hermit warbler. Basically, this was my job exactly, was to look at these spectrograms and listen to the recordings to identify which of our indicator species, our species of interest, were in the recording that day. So I listened to 43 of these surveys, looking out for 10 selected indicator species. This gave me a lot of experience with this passive acoustic monitoring methodology. So I paired that with a little literature review focused on a couple of different topics: the current selection criteria for indicator species, the anticipated effects of climate change on bird populations on the Olympic Peninsula, and the current state of passive acoustic monitoring research and application for songbird detection. And then finally, with that third research objective, I wanted to evaluate DNR's indicator species and data with consideration of the new criteria that I was developing. So in my preliminary findings on the topic of climate change, this turns out to be a very complex issue. Indicator species diversity is the key to climatic resilience, right? So if we want to have indicator species that are still going to be relevant 50 years from now, the idea is that we want to choose those that might be resilient to climate change. However, we don't know what climate change is going to look like on the Olympic Peninsula, what those effects are going to be specifically. So that's really hard to anticipate. And then also another complication is that indicator species, by definition, are supposed to be very responsive to changes in habitat, right? Because we want to know if something changes, they'll probably leave. That's what makes them a good indicator of whether that change is actually happening or not. So the idea is that if we want them to be resilient 50 years from now, we don't want them to be responding to climate change. But if we want them to be good indicators, we do want them to be responding to climate change. And the answer to this catch-22 is to select a very wide diversity of songbirds that might have very different responses to the impacts of climate change. And by looking at the disparate impacts on different species, we can identify what the changes are that are truly affecting these indicator species. And despite the ambiguity of climate change, there are some macro effects that we can anticipate. We've got a pretty good understanding of range shift and how that might be affected by competitive displacement, as well as what some extreme weather events might look like for the Olympic Peninsula. As far as my findings for passive acoustic monitoring, the biggest thing is sound-alike limitation. So as you can see here, I've got spectrograms of the pileated woodpecker and the northern flicker. These two here to the left are pileated woodpecker. This one's northern flicker. Very difficult to tell apart visually. And also I'll play a little recording. First one's pileated woodpecker and northern flicker. As you might be able to tell, though, they're pretty difficult to tell apart. Even our computer programs had a little bit of difficulty telling them apart at times. So limiting these sound-alikes is a major issue here. Also limiting hybridization, because that causes difficulty with identifying the songbird calls, and prioritizing songbirds with unique vocal timings and behaviors. Just a quick little overview of some of the most difficult DNR species. The Buick wren is yet to be detected. We don't know exactly if it's because it just doesn't exist there or because it's not singing. And then the orange-crowned warbler is too similar to the dark-eyed junco, in my opinion, and the pileated woodpecker is too similar to the northern flicker. So just to close us out here, a couple of conclusions. Considering passive acoustic monitoring while selecting indicator species will improve efficiency in research. Anticipating the responses of indicator species to climate change can prolong and expand study relevance. And there are some improvements that we can make with current DNR indicators by reducing sound-alikes and offering a greater diversity of climate responses. Thank you.